So today we will see more examples that we should know about a difference between reflexive relation and identity relation. So I'm taking some examples to explain you about it. Let we have a function, we have a relation on the set, and the elements of set are 1, 2, 3, 4. Okay, and then if I will ask you that if R1 is a relation on the set A, which is defined by having the elements 1, 1, 2, 2, 3, 3. Okay. And let R2 is a relation which is defined as has the elements 1, 1, 2, 2, 3, 3, and 4, 4. And R3 is another relation defined on the same set, and it has elements 1, 1, 2, 2, 3, 3, 2, 2, 3, 3, 4, 4, and 1, 2. 4, 4, and 1, 2. So we have to check identity relation and reflexive relation here. So what is the difference between identity and reflexive relation? So what do you say that R1 is reflexive or not reflexive? For reflexive relation, all 1, 1, 2, 2, 3, 3, 4, 4 must be there. So it is not reflexive. It is not reflexive because 1, 1, 2, 2, 3, 3, 4, 4, all we will see here. Okay. But it is an identity relation. But it is an identity relation. Identity relation. In identity relation, they should have only doublets. It can have less than, more than, it can have less than the number of elements in the set A, 1, 1, 2, 2, 3, 3 only. If you will put one more, for example, R3, here 1, 1, 2, 2, 3, 3, 4, 4, but 1, 2 is the extra element of the relation R3, so it is not identity relation. So in identity relation, all doublets should be there, only doublets. We can say in our language, only doublets, if only doublets are there, then we can have the relations as an identity relation. So only doublet, no other number should be there, then it is an identity relation. For in our language, we are just taking this doublet for understanding better. Otherwise, it is for all A belongs to A. For all we will not take. For all we will take for reflection, and this one for this one we will not take for all. So okay, so reflexive now this is all 1, 1, 2, 2, 3, 3, 4, 4. So all four elements have their combination with itself. So it is reflexive relation. It is reflexive, and as well as it is also identity relation. It is also identity because it is not having an element which is not related to itself. But here, if you will see here, all four elements are related to itself, so it is reflexive relation. It is reflexive, but it is not an identity relation. It is not an identity relation. Okay, understood? So in identity relation, only that number should be related to itself. And other numbers, if are there, then it is not an identity relation. Okay. So we can more understand by taking some examples. Uh, Suppose same set A, we are taking set A 1, 2, 3, and 4. Now you have to tell that R1 first is our relation R1, which is having the elements 1, 2, 2, 3, and 1, 1. Okay. We have to tell whether it is, we have to check for transitive, reflexive, and symmetric. So tell me whether it is symmetric or not. How to check the symmetric? First, okay, we will start from uh, symmetric. Okay. Reflexive, we can start from reflexive. Okay. What is reflexive relation? So it is reflexive or not? It is not reflexive because in 1, 1, 2, 2, 3, 3, 4, 4 should be there. So it is not reflexive. Number one. Then symmetric. For symmetric, what we will check? Symmetric means AB belongs to, if 1, 2 belongs to 2, 2, 1 must belongs to this one. Then it is symmetric. So here 1, 2 belongs, but 2, 1 does not belongs to R1. So it is not symmetric. Transitive, if 1, 2 belongs to this and another number is there. If it is not there, we will leave it. But if it is 1, 2 and 2, 3 is also there and then 1, 3 must be there, then it is transitive. So here 1, 2 is there, but 2, 3 is also there, but 1, 3 does not belong to this. So it is not transitive. It is not transitive. Okay. And now we'll take another example. R2, suppose R2 is a set of elements. Now you can tell me 1, 2, 2, 1, 1, 1, 2, 2, 3, 3, and 1, 3. Okay. Now you have to check reflexive. First, it is reflexive or not. Tell me whether it is reflexive or not. Hello, Mudassir, is it reflexive?
Yes, sir.
Is it reflexive?
Reflexive. Yes, sir.
Yes. No.
Yes.
No.
Probably, sir.
Where is 4, 4? For reflexive, you have to check 1, 1, 2, 2, 3, 3, 4, 4. All numbers. Here 4, 4 does not belongs to this one. 4, 4 does not belongs to R1. We will write
Okay. Yes.
R2. Therefore, R2 is not
Reflexive.
reflexive. Correct? R2 is not reflexive. And this is also not identity relation. Then symmetric. For symmetric, what we have to check, we will start from first one. Okay. 1, 2 belongs to this. Okay. 1, 2 belongs to R, implies that 2, 1 belongs to R. And no need to check 1, 1, 2, 2, 3, 3 because 1, 1, 1, 1 will be 1, 1, 1, 1. Okay. And 1, 3 belongs to this one, but 3, 1 does not belongs to this one. 3, 1 does not belongs to this one. So therefore, it is not symmetric because 1, 3, if 1, 3 belongs to this one, R, this is R2, then but 3, 1 does not belong to R2. So therefore, it is not symmetric, not symmetric. Okay, are you understanding? And for transitivity, what we will check? First, we will check this 1, 2. 1, 2 is there, 2, 2 is there. If 2, 2 is not there, we will leave this one. We will check, okay, 1, 2 is there, 1, 2, and 2, 1 is also there. 1, 2, and 2, 1 belongs to R2. And this implies that 1, 1 should belongs to R2. Okay, 1, 1 also belongs to R2. Okay, transitive. Then 1, 1, 2, 2, 3, 3, you leave. These will always give you transitivity, symmetricity, all. Okay, got it? Because 1, 1 will be 1, 1 only, that's why. But here, any other number is ending with 1, 1. Yes, this one. 1, 1 and 1, 3. 1, 1 and 1, 3. But 1, 1, 1, 3, if you will take 1, 1, okay, 1, 1 and ending with 1 is another element, 1, 3. Okay, these two belongs to R2. That implies that 1, 3 should belong to R2. So 1, 3 is already there. 1, 3 is itself this one. So this is also following this one. Okay, so got it. So 2, 1 and 1, 1. Then 2, 1, 2, 1 we can take 2, 1 because 2, 1 is ending at 1. So any other number which is starting from 1, so then we will take these two. If it is not starting, we will leave it for transitivity. That will not prove that it is not transitive. We will find 1, 2 and check that is there any number which is starting from 2, and then we will take the third one. Similarly here 2, 1 and 1, 1. If you take 2, 1 and 1, 1, so 2, 1, again 2, 1 will come because you know that 2, 1, 1, 1 belongs to R2, then 2, 1 will also belong to R2. So all are belonging. So therefore, it is transitive. R2 is transitive. Are you getting my point? So you have to analyze actually. We have to analyze the relations. What are the numbers coming in that relation? Sometimes we have given like this ordered pair. Sometimes we have given the application. So we should think over it. We have to analyze that what type of numbers will be there. Whether all numbers will belong, doublets will belong or not. So like this. So now we are taking third example. Now you have to tell me just fast. All the three things you have to tell me. Uh, First 2, 2 and 3, 3. Yes, Mariam, tell me whether it is reflexive or not. Is it reflexive? Reflexive? We have to check reflexive and then symmetric. Whether it is reflexive or not. Hello? Yes, tell me. Tasneem, uh, whether it is reflexive or not. It is not having 1, 1, 2, 2, 3, 3 and 4, 4 is not there. So it is not reflexive. And for symmetric 1, 2, 2, 1, 1, 1 is there. 2, 1, 1, 1. So 2, 1 will come. 2, 3, 3, 3, 2, 3. For transitive, sorry, reflexive 1, 2, 2, 1 is there. Okay, 2, 3, 3, 2 is not there. 2, 3 is there and 3, 2 is not there. So it is not symmetric. It is not symmetric. And transitive, for transitive, we have to check 1, 2, 2, 1, 1, 1. Okay, 1, 2, 2, 1, 1, 1 will make a combination. Okay. Then 2, 3, is there any number? Yes, which is starting with 3, it is ending with 3 and starting with 3. So 2, 3, 3, 3, 2, 3. Again, this 2, 3 will come. Okay. 1, 1, 2, 2, we are not taking. And 2, 1, 1, 1, 2, 1 will come. 1, 2, 2, 1, 1, 1 will come. So all are here making the transitivity true. So transitive, it is transitive. It is transitive. Okay. So this is transitive but not reflexive, not symmetric. So I think you understood better. Now I'm writing some same R3 or R4. You can check the same A is the set of elements 1, 2, 3, 4. So you have to find out and send me on WhatsApp that this R4 was reflexive, symmetric. Not now, later on. Just you can note down 2, 2, 3, 3, 4, 4, 3, 3, 4 4 1 2 2 1 and 2 3. Check for reflexive, symmetric, and transitive. R4, R5, and identity also check. 1 1 2 2 3 3 4 4 3 3 and 4 4, but 1 2 is also there. So R5, R6, R6 is having the elements 1 1. You can note down 2 2 3 3 4 4 1 2 2 1 2 3 and 3 2. Check it. And one more R7 is 1 2 and 3 4. Okay, so you will check and get back to me. You have to see the difference between relation and function. We have seen the relation like we are denoting the relation by diagrammatically. This is diagrammatic representation of relation, that A set A. If it is from A to A, we will write both A to A. If it is from A to B, we will write A to B. So from A to B, suppose we have a number A. It's these are two different sets. So the image of A is 1, the relation. Okay. B also has this image 1. Okay. And C is having image 2. This is called the image. The image of C is 2, image of B is 1, image of A is 1. Okay. And A can have one more image in relation. A can have, this is the image of A, 1 is the image of A. Okay. And if there is another number here, 3, and image of A is also 3. So that means A has two images. What we have concluded here, that A in one element, there is one element in domain has two images. Okay, has two images. Okay. Now we take another example where we will have one more thing. D can also be here. One element can be left which is not having any image in D. Then it is a relation. But in function, every element, first of all, every element must have the image and unique image. There are two things in function we have to remember. Two things. Number one, every element has image. Every element must have image in B. Okay, in short. And okay, image, but image here also every element, if D is not there, every element will have, but A will have two images. And every element has a unique image, but their image should be unique. Here it is not unique. A has two images. So every element, and they have unique image. Every element has a unique image. Unique image. What do you understand by unique image? You can see that here try to understand that A is an element in the domain and its image is 1. Okay. And B has an image also 1. And C has an image 2. So can you say that every element has a unique image? Mudassir, every element has a unique image? Yes, it is. Because you can say the image of A. What is the image of A? Image of A is 1. Image of B is also 1. Unique image. The image of B is 1 only. Unique. It is not having two images. And image of C is also only unique image 2. So when every element of A is associated to each element of set B, every element should be associated. There should be no element left here, and every element has a unique image. Or now you can say that this V here, this V is possible, means one element can have two images, but here it is not possible. This V is not possible, but it is possible here. Two elements can have same image, but one element cannot have two images. Then it is a function. Means relation is a special type of function, or relation is a rule which assign the elements of A to B such that every element of A has a only one and one image in set B. So how we will define now relation can be defined in many ways. So a relation function can be defined in many ways. A relation from the function is a relation, but it is restricted relation. So a relation from set A to set B is said to be a function. Is said to be a function if and only if every element of A, we can write in many ways. Every element we can write in two sentences. We can write in, if we say every element of set A, means every element of set A must have the image, has one and only one image, has one and only one image in B. You can see that B has only one image, that is 1. It can be any number, but has only one image. So every element of set A has one and only one image in set B. Only one image in set B. Okay. But one more thing. Here one number can be more which is not having any image of that number. Here one number can be left, but here cannot be left in set A. So if it is more than this, then the codomain and range will be same. What is codomain and range? And domain. So here domain, what will be the domain? And it is denoted by the set is all function is also called mapping. The function is also called mapping. You can say mapping also. So it is denoted by function. How we will write the function now? We are not writing relation like that. So it is denoted by, it is a function f. So we will write f from set A to B. And if it is defined, suppose it is defined by f is equal to x square. So we say f is a mapping from A to B defined by f is equal to x square. Now here you can see the domain. What is the domain? Set A is always a domain. So no need to think more about the domain. Domain is the set A. Okay. And set B is always codomain. Codomain. But codomain can be equal to range and cannot be equal to range. If it is equal to range, then we will see onto or into function also. We will check there the kinds of functions that we will study next. So domain and codomain. Codomain is what? Set B. But here you can see this is the range. What is the range? Range is 1 and 2. This is range. This is 1 and 2 set is a range. This is a range of the function. And 1 to 3, if you add, this is codomain. Set B is codomain, codomain, and set A is domain. So codomain can be equal to range, cannot be equal to range. It depends. So then on that basis, the name of the function becomes onto and into. So before that, we have the kinds of function one, onto. So try to understand the difference between relation and function. Okay, so every element has a unique image. But that is the only sentence you can remember. Every element of A has a unique image in P. One and only one means unique image. So we can write in one sentence every element of A. How we will define function? Every element of A has a unique image in P. Then it is a function. So every, how we will define, let A and B be two non-empty sets. Then every element of an A is a mapping from set A to B is said to be our relation from A to B is said to be a function if every element of A has a unique image in B, has a unique image in B, unique image in set B. Okay. Now, therefore, when we are going to analyze the functions, we have to check A is a element of natural numbers or real numbers or positive real numbers or negative real numbers or integers, whatever it is. So accordingly, we will find out whether it is a function or not, or which kind of function is this. We have now kinds of functions. In kinds of functions, first we will see we have two types of functions. Kinds of functions. First is one function. One function. What is one function? Means every element, one element has one image. Means if this is a set A and this is set B, okay. So if A element, before that we have seen that A will have one image only, B will have another image. They should not have the same image. They can have the same image in function. C will have another image, 3. So one element has one image. That's why it is called one. One element here will have one image. So one function is the function, a function. So how we will write the definition of function f from A to B set. A function f or mapping defined from A to B is called one. It is a function, but when it is one, when every element of A has one image, means if it has different images, means A has its image 1, B has its image 2. So they have different images. So different elements, what we can say, different elements have different images. In other way, we can say it's called one, if and only if different elements of A, different elements have different images. Different elements of set A, different elements of set A have different images, in set B, have different images in set B. So different elements has different images. So thus we should write like this. Thus mathematically, if F is a mapping from A to B is 1. If it is 1, this implies that or implies by A, if A is not equal to B, implies that F A will not equal to FB. For all AB belongs to the set A, for all AB belongs to set A, AB will belongs to set A only. Okay, and or we can say that if A is equal to B, if A is equal to B, or if A is equal to FB, if FA is equal to FB, implies that A is equal to B for all A, B belongs to A. So for proving algorithm, I am telling you the algorithm how to prove that this is A, this is 1, 1. So we will prove, we can have the proofs or algorithm to prove the given function 1, 1. Algorithm is steps how to prove that it is the given function is a 1, 1 function. Okay. So first step, what we will write first, take any two arbitrary elements in the domain of F. Take any two arbitrary elements, arbitrary elements x and y in domain of the function f, domain of the function f. And then second step, we will put fx is equal to fy. Are you understanding? Fx is equal to fy. Like I'll give one example, you can understand better. Then step number 3, solve. This we will solve. Solve fx is equal to fy, and it gives that x is equal to y. If it gives that x is equal to y, if x is equal to y, we get, if x is equal to y, only then f is 1, 1. Only then f is 1, 1. For example, that is defined from natural number n to n. Okay, by the definition, fx is equal to x, fx is equal to x. Suppose fx is equal to x. So here in natural numbers, first you have to write this is the set of natural numbers. So it will have infinite numbers 1, 2, 3, 4, and so on. Here also you will have 1, 2, 3, 4. But fx is equal to x means if you will put 1, image of 1 will be 1, 2 will be 2, 3 will be 3. Okay. So this you can first check. Then what will be the algorithm? You can take let x and y belongs to the function f, a domain of f, है ना? Domain of fx, then put fx is equal to fy, fx is equal to fy. So fx, what is the formula of fx? It can be x square, it can be x square, it can be sin x, any function. So here I'm taking a simple example, x is equal to y. So therefore fx is 1, 1. So like this we will prove 1, 1. Now next topic is, when a function is 1, 1, it is called injective function. 1, 1 function is called, also called, 1, 1 function is also called as injective function. It is called injective. Sometimes they are using this word, prove that it is injective function. So we have to prove this one. Second part is onto function. We have to do actually together onto function today. But